Hello everyone, today I want to assemble a fairly simple homemade. The scheme of the device is simple, but it allows you to get a very interesting, very beautiful visual effect. If you have not subscribed to the Invex Lab channel yet, then click the subscribe button and we will start assembling today's device without delay. To make it easier to give the wire the desired shape, I first transferred all the dimensions to paper. LEDs will be mounted on this workpiece at regular intervals, which had to bend their legs a little before soldering. Now you need to connect the LEDs into groups of 3 in each. The LEDs are connected in parallel as follows. As for the 5th and 10th groups, the connection of the LEDs looks like this. At this stage, a significant problem has appeared. Some LEDs turned out to be either defective, or from another batch. But their glow is significantly different compared to others. Well, what about it? Since I have nothing to replace the LEDs with, I decided to use these SMD LEDs made of LED strip. By the way, I already have experience using such LEDs here. In this video, I collected a very interesting thing from such SMD LEDs, a very interesting homemade. The link to this video will be in the description. And today we will have to go the same, much more time-consuming, longer way. It turned out to solder the LEDs to the base quickly enough, but it took me more than 1 hour to connect them into groups. I numbered the outputs of each group of LEDs so that I would not look for them when connecting them to the chip. So, this part of the DIY with LEDs is ready. Now you can start assembling the rest of the circuit. First of all, I will make a frame out of copper wire. The principle of operation of this scheme is quite simple. Conventionally, the scheme can be divided into two parts. The first part is based on the NE555 timer, whose task is to generate pulses. The second part is built on the CD4017 chip. This is a decimal counter that counts pulses and consistently supplies voltage to its terminals, lighting the corresponding LEDs. By changing the nominal value of the resistor R2, you can change the frequency of the generated pulses, and therefore the speed of the running lights. This CD4017 chip is a counter that has 10 outputs. When clock pulses are applied to the input of this counter, a logical unit, that is, the output voltage, appears at the first output of this counter, and then moves sequentially through all the other outputs. This whole process is cyclical, that is, it is repeated many times. In this scheme, as diodes VD1 and VD2, it is best to use Schottky diodes, which have a low voltage drop and have high performance. But they can be replaced with other diodes that are more or less suitable in terms of parameters. For example, I will use germanium diodes D9, which also have a low voltage drop, which is the main factor in this scheme. The result was this design. Let's call it a mounted installation in a 3D image. Now I will connect the two parts of the homemade into one and connect the LEDs to the chip. Everything is ready. The supply voltage of this homemade is 5 volts. A smartphone charger can be used as a power source. This concludes this video. If you liked today's homemade, then do not forget to subscribe to the InvexLab channel. And also click on the bell icon next to the subscribe button to receive notifications about the release of new videos on my channel. I thank you for watching and bye.